Hello Algebra 1 students, this is Mr. Wilsey, and in this video we are going to be solving some more complicated linear equations. So I want you to title your notes, which you should always be taking as you're watching my videos, Solving Linear Equations. I know my face is in the way, I'll move it in a second. Part 2. I just want you always to see my face to know that I'm still here. Still human. It's me, I promise. I didn't hire anybody from, outside the country to make my videos for me. Okay, I am gone now. Alright, solving linear equations part 2. Alright, so we're going to look at some more complicated equations that require a couple more steps and some more critical thinking in order to figure out how to solve them. Alright, so here's the first equation that I want to solve. So you're writing this down with me. 5 equals 5m minus 23 plus 2m. All right, let's figure out how we're going to solve this equation for m. Now the first thing you might notice is that, m appears in two different places. Well, that's a bummer because in order to solve this equation, we eventually want to write the equation like this, m equals one number, all right? So we have to somehow find a way to combine these two m's into a single m, and that will eventually be the m that goes over here. The question is, how do we do that? Well, in this case, notice that the 5m and the 2m are on the same side of the equation. This means that we can do a little trick that you might have heard before. We can combine like terms, okay? 5m and 2m are like terms because they both have an m raised to the first power, okay? There's an invisible first power out here. Now what that means is that we can simply add 5 plus 2. So 5 plus 2 is 7. And then a 7 is going to be multiplying m. Everything else about the equation stays the same. 5 equals 7m minus 23. So now this equation looks like the ones that we studied in the last video. In order to solve this equation for the now single m that we have here, we have to add 23 to both sides. 23 plus 5 gives us 28. Equals 7m, and then finally we divide both sides by 7. 28 divided by 7 is 4. Alright, so we solved our first equation where m appears multiple times, where the unknown appears multiple times. So let's try another equation like this, except it's going to be even more challenging. So how about 6y plus 3 minus y equals 21 minus 4 times y. So now you'll notice that y appears not just twice, but 3 times. 3 times. First of all, over here, on this side of the equation, we can deal with the 6y and the minus y in the same exact way that we did in the last problem. We can simply take the 6 minus what? What does this mean over here? Well, remember that anytime you see a minus sign in front of a number or an unknown, in this case y, you can imagine there being an invisible 1 out here. So what we're really doing is taking 6 minus 1, and that becomes 5, and that becomes a number that multiplies our unknown, y. Everything else about the equation will stay the same. Plus 3 equals 21 minus 4y. Alright, so now we've gotten from 3 y's down to 2 y's. Where do we go from here? Well, you might be tempted to say 5 minus 4 equals 1. So 1y plus 3 equals 21. But that is wrong. Do you see why it's wrong? Notice what is different about this situation compared to the last two situations. We cannot simply take 5 minus 4 in this case because over here, this is on the opposite side of the equal sign as the 5y. So we can't simply combine like terms yet. Here's what we have to do first. We have to get the 4y on the same side of the equation as the 5y. Now how do we do that? Well, just as if we would have to move anything to another side of the equation. You do the opposite of what is currently happening to that 4y. In this case, what is happening is that 4y is being subtracted. So in order to move it to the other side of the equation, we have to add 4y. Now don't just say add 4. You have to add 4y. Alright? Do that to both sides of the equation. Now, this will cancel out on the right-hand side of the equation, leaving us with 21. And then over here, we have 5y plus 4y. That gives us positive 9y. And then, of course, we have a plus 3 hanging out. All right, now this equation looks exactly like the ones we studied in the last video. Subtract 3 from both sides to get 9y equals 18. And then finally divide both sides by 9. Sorry, ran out of room, to get y equals 2. And that is the solution to our original equation. Okay, let's look at another example. You're going to hate me for this one. I know you are. 3 times x divided by 4 minus x divided by 3 equals 10. So why do you hate me? Well, I hope you don't actually hate me, but if you slightly dislike me a little bit more than you did a second ago, it's probably because we have division happening here, okay? And if you're very clever, you'll notice that these are actually fractions, okay? And we can actually rewrite this whole left side of the equation to make it clear that we're dealing with fractions here. 3 over 4, so 3/4 times x minus, well, what do we do here? Because there's no number out here. But remember, we can always pretend that there's an invisible 1 out front. So if we do that, we see that this is 1/3 times x equals 10. So what in the world do we do here? Well, in the previous equations that we looked at, we kind of skipped over this step. Let me go back to this equation here. If we were to just look at the 5m and the 2m, so 5m plus 2m, watch this. I'm going to use the reverse distributive property, as I call it, to take out the m. And then what's going to be inside the parentheses? 5 plus 2. If we were to go backwards, starting with this line and going up here, all we would do is distribute. M times 5, m times 2. Do you see that? We're just going backwards with the distributive property. And then look here, we get 5 plus 2 gives us our 7, and then times m. Okay? So I just used the reverse distributive property to get here. And this is the essence of combining like terms, is using the reverse distributive property, except kind of hiding that we're doing it. So let's use this fact right here. Notice that there is an x here and an x here. So what I'm going to do is use the reverse distributive property to pull out the x from both of those fractions. Watch this. X times, and then in parentheses we're going to have 3/4 minus 1/3. Okay, equals 10. Now, look at what we have in here. We simply have one fraction minus another. Now, in order to subtract these fractions, we need to find the common denominator, which in this case can be found by simply multiplying the 4 and the 3 to get 12. So, how do we get these two fractions to have a common denominator of 12? Well, we need to multiply the right fraction by 4 on the bottom and on the top. So 3 times 4 gives the 12 on the bottom, 1 times 4 gives 4 on the top. And then the right fraction we need to multiply by 3 on the bottom and on the top. So we have 9 over 12 right there. Everything else about the equation stays the same. I'm going to bring it up here. So now we have 9 minus 4, which gives 5, over 12 times x equals 10. So what do we do from here? Well, we have a 12 in the bottom of the fraction. So in order to cancel that out, we can multiply both sides of the equation by 12. This cancels out. Multiply by 12, divide by 12. So we're left with 5 times x equals 120. Finally, we can divide both sides by 5 so that we find that x equals 24. And that's it. We have found our solution. Okay, so that problem wasn't too bad. Now, let's try another one. How about 3.5 minus 0.02x equals 1.24. Now, this is actually a very simple equation in form. The only different thing about it compared to other equations you've looked at so far is that all of these are decimals. However, the equation solving process is exactly the same. First thing we're going to do is we're going to isolate the x by moving the 3.5 and the 0.02 to the other side of the equation. Which one do we do first? Well, work our way in toward the unknown, so let's move the 3.5 first. We move it by subtracting 3.5 from both sides of the equation, so we are left with negative 0.02 times x equals 1.24 minus 3.5. Negative 2.26. Then finally, we are not going to add 0.02. That doesn't make any sense. This number is multiplying the x, so we have to divide both sides by negative 0.02 in order to take it off the x. So this gets canceled out, leaving us with x on the left-hand side of the equation. And over here we have negative 2.26 divided by negative 0.02. There we go. Positive 113. So x equals 113. Okay, so that equation was not too bad either. We just had to use our calculator to deal with the decimals. Okay, let's try another one now. Okay, so this one is going to be number 5. I forgot to number the last one. 18 equals negative 3 times, in parentheses, 2x minus 5. Okay, in order to solve this equation, remember that we need to isolate the x. So we need to get everything on the same side of the equation to the other side. This means the negative 3, the 2, and the 5. Now, there's actually two different ways that we can approach this equation. One way is to begin by distributing the negative 3. That way we get rid of the parentheses. So this would become 18 equals negative 3 times 2x is negative 6x, and then negative 3 times negative 5 is positive 15. Okay, so now we have an equation that you can easily solve right here. The result is negative 3 over 6, which of course can be reduced down to negative 1/2. Okay, so this is the answer that we get if we distribute to begin with. But actually, there's another thing we can do to begin solving this equation. Let me show you the alternative way. What if, to begin with, we actually divided both sides by negative 3? You see that? So in this case, 18 divided by negative 3 is negative 6. This is going to be equal to, now notice that the negative 3's cancel out, leaving us with 2x minus 5. We don't need to put parentheses around the 2x minus 5 anymore, because that's the only thing on that side of the equation. Then we add 5 to both sides. Negative 6 plus 5 is negative 1. And then finally we divide both sides by negative 2. And Not surprisingly, we get the same exact answer that we did before. X equals negative 1/2. Now, compare these two methods. This method, we distributed first to get rid of the parentheses. This method, we divided off the negative 3. It's up to you which method you choose whenever you're solving equations like this. Okay, let's look at another example. 4 minus 8 plus 3x inside of parentheses equals negative 1. Notice that we have a set of parentheses right here. And in general, anytime you see a set of parentheses, one thing that you can do, and the thing that is usually the best thing to do, is to distribute. Okay, just like in the previous problem, we saw the set of parentheses, and we distributed the negative 3. Okay, you always can do that, and sometimes it's best to do that. In this problem, though, there's nothing out here to distribute. So, can we still distribute? Well, yeah, of course. Remember that there's actually an invisible negative 1 out front. So we just distribute a negative 1. So let's do that. If we distribute the negative 1, this equation becomes 4. Negative 1 times 8 is negative 8. And then negative 1 times 3x is negative 3x. Okay? Then from here, we use order of operations to simplify this. The 4 minus 8 is negative 4 out front. And then finally, we have an equation that looks familiar to us, or at least familiar in form. To solve this equation, just add 4 to both sides. Negative 3x equals negative 1 plus 4 is positive 3. Divide both sides by negative 3. X equals negative 1. Okay, so that wasn't too bad. The key to solve an equation like this is just to recognize that there's always an invisible 1, possibly with a negative sign, in front of any set of parentheses that doesn't apparently have a number in front of it. Okay, I think there's just one more equation that I want to look at with you. This is number 7. Sorry, I've been really bad about numbering these. 2 times in parentheses 5x minus 1 equals 3 times in parentheses x plus 11. Okay, so notice what we have here. We have two x's on opposite sides of the equation. Not only that, but we have two sets of parentheses with a number multiplying it out front. So this becomes sort of a complicated equation, but it's one that we can easily tackle using all the tricks that we've seen in this video. So again, remember, anytime you see a set of parentheses with a number multiplying it out front, it never hurts, and it's sometimes actually the best thing, to distribute that number into the parentheses. So let's distribute the 2 on the left-hand side. 2 times the 5x gives 10 times x. 2 times the negative 1 gives negative 2. This is going to be equal to 3 times x gives 3x, and then 3 times 11 gives plus 33. Okay? Now, whenever you have an equation that looks like this, we need to get the x's to the same side of the equation, and we need to get everything else to the other side of the equation. Okay? That's our first step here. So, in order to move the 3x to the left side of the equation, we have to subtract 3x. Okay, subtract the whole thing. That way this thing goes away on the left-hand side of the equation. So subtract 3x from both sides. Right here we have 10x minus 3x. Those are like terms. They become 7 times x. Everything else about the equation stays the same. Okay, got this. Now let's move the 2 to the other side of the equation. We do that by adding 2 to both sides. 7x equals 35. And finally, we divide both sides by 7. Okay, so this equation was not all that bad either. 35 divided by 7 is 5. All right, that is it for solving more complicated linear equations. Again, we use the distributive property in this video. We use the idea of the invisible 1 or possibly invisible negative 1. We used the idea that there are multiple ways to solve an equation like this. What else did we use in this video? Oh, we dealt with decimals. Okay, decimals are scary, but we also dealt with fractions, which are probably even scarier than decimals in my opinion. We use the idea of combining like terms when things are on the same side of the equation. We also use the idea of moving a term that has the unknown attached to the other side of the equation in order for us to combine like terms, because we can only combine like terms if they're on the same side of the equation. And finally, we saw how combining like terms comes from this idea of applying the reverse distributive property. Okay, so hopefully you learned a lot in this video and you are ready to begin practicing.